In this video, we are going to learn how to write the electron arrangement of an atom, how to draw the electron arrangement, and how to draw the atomic structure, which is slightly different. Let's get right into it. So this example that you see on the screen is a drawing of the electron arrangement of an atom of element X. So we start with the center. This circle here represents the nucleus with the symbol of the element. So you can see X is right in the middle of it. Outside of the nucleus, you can see we have three circles. These circles are actually the shells in which the electrons are orbiting. And then the number of shells is numbered from inside out. So the first shell will be the one right inside here, just outside the nucleus. Just outside of that, we have the second shell, and finally the third shell. And for the atomic structure, you can see that it is similar but slightly different in that the nucleus is actually labeled with the number of protons as well as the number of neutrons. Alright, so the electrons actually orbit the nucleus in shells, as we saw earlier, and the first shell must be filled up first. Once the first shell is full, then the second shell will start to be filled up, and the third shell, and so on. Now the maximum number of electrons in each shell differs depending on the number of protons. So if the atom has 1 to 20 protons, that means the proton number is from 1 to 20, that is until calcium in the periodic table of elements, then the maximum number of electrons that can fit into the first shell is 2. Once that's full, then the second shell will start taking in electrons, and the maximum number that can fit in the second shell is 8. And finally, the third shell can also fit a maximum of 8. Now this is slightly different when the number of protons exceeds 20. So 21 onwards. 21 onwards, the first shell can still take 2, second shell still takes 8. However, the third shell can take up to 18. Now let's get to the electron arrangement, the written electron arrangement. When we write the electron arrangement, this is how we write it. This is an example of a written electron arrangement. So the first number represents the number of electrons in the first shell. And then we use a dot to separate the shells. So this number 8 will represent the number of electrons in the second shell. Once again, we use a dot to separate it from the third shell. Now the third shell is a bit special. In this case, it is the outermost shell, the shell on the outside of the atom. There's a special name for the electrons here. These are called valence electrons. The electrons in the outermost shell are the valence electrons. So this particular atom would have 5 valence electrons. This is very important for reactions, which we will learn later. I have another video for that. You can look for it in my chemistry playlist. Now, for a helium atom, let's try this example. Write the electron arrangement. So where do we get all the information for the helium atom? We can get it right from the periodic table. So if we look at the periodic table, this is where helium is. The smaller number here represents the proton number. So we know that helium has 2 protons. Now for an atom, the number of protons is equal to the number of electrons. Therefore, we can also conclude that it has 2 electrons. Now that we have the number of electrons, we can write the electron arrangement. So for helium, the electron arrangement would simply be 2. The first shell can take a maximum of 2 electrons, and all of it can fit into the first shell. So that's it, just 2. Now how to draw the electron arrangement? So let's draw the nucleus first. The nucleus must contain the symbol of the element, He, for helium. Draw a circle. This is the nucleus. And then we draw the first shell. So the first shell will be just outside the nucleus. And the number of electrons that are occupying this shell is 2. So we can use dots or we can use cross. So this one I'm using dots. We just draw 2 dots. We usually draw them on opposite ends, one up and one down. So this is the electron arrangement drawn. Now what about the atomic structure? So for the atomic structure, we need the number of protons, which we have. We have 2 protons. But now we also need the number of neutrons. So once again, let's go back to our periodic table. So if we look at the bottom, this number represents the number of nucleons. So there are 4 nucleons, which is the total number of protons and neutrons. So how do I get the number of neutrons on its own? I simply have to take the nucleon number 4 and subtract the number of protons, which is 2. And so the number of neutrons is 2 as well. And that's it. That's the number of neutrons. So now we can label it here in the nucleus. So this will be 2 neutrons as well. So let's draw a circle. So this represents the nucleus in the atomic structure. Now we draw the shell as we would in the electron arrangement. The first shell, this time I'm going to use cross instead of dot. So we have 2 electrons. And we're done. This is the atomic structure of helium. Now this is one shell. Let's try an element with 2 shells. So let's try lithium. So first we need to figure out how many electrons we have to arrange. So for lithium, lithium has a proton number of 3, which means it has 3 electrons as well. So let's fill it up. So the electron arrangement, we have 3 electrons to fill. The first shell can only take 2, a maximum of 2. So now we have a balance of 1. The 1 electron will now have to go into the second shell because the first shell has been fully occupied. So now we draw a dot, we write a dot, and then 1 for the number of electrons in the second shell. And now we are ready to draw. So when we draw this, once again, we draw Li here, the center. And then we draw 2 in the first shell. So I'm going to use cross this time. And then we have 1 more in the second shell. And we're done. This is the electron arrangement drawn. Let's go for the electrons, the atomic structure. So the atomic structure, we need the number of protons, which we have, 3 protons. But now we need the number of neutrons as well. Once again, we go to the periodic table. The nucleon number is 7. So the number of neutrons would simply be the nucleon number minus the proton number, which is 4. So we have 4 neutrons in the atom of lithium. So let's write 4 neutrons here. So this is the nucleus. Now let's draw this first shell. First shell, I'm going to use dots, has 2 electrons. And the second shell has 1 electron. And we're done. This is the atomic structure for lithium. Let's try an atom with 3 shells. So let's do magnesium. Alright, so let's look at magnesium in the periodic table of elements. This is magnesium. So I've already done the calculations here. Magnesium has 12 protons, so 12 electrons, and the number of neutrons would be 24. Nucleon number minus the number of protons, which is 12. So let's draw this. First, let's write the electron arrangement. So 12 electrons to arrange. And the first shell can only take a maximum of 2. We have a balance of 10. The second shell can take a maximum of 8. So what's left is 2 electrons. And these 2 electrons will be forced to go into the third shell. So 2, 8, 2. Done. This is the electron arrangement. Let's draw that. So once again, we need the symbol of the element in the nucleus, Mg, for electron arrangement. This is the nucleus. First shell fits 2. Second shell fits 8. Alright. So the way that we usually draw electrons in the shell is that first we would fill 4 like this. We would draw 4 on all 4. There's no corners in the circle, but north, south, east, west. And then we would start filling up one by one. So 5, 6, 7, 8. This is how we usually draw it. We draw electrons in pairs. And then for more than 4 electrons. And then the final shell, which is the third shell, has 2 electrons as well. So 1, 2. So this is the electron arrangement for magnesium. What about the atomic structure? Just now we have already calculated it has 12 protons as well as 12 neutrons. So this is the nucleus. Time to draw the shells. So first shell, I'm going to use cross here. 2, second shell. Once again we arrange them in pairs. For electrons that are more than 4 in a single shell. Okay, and then the last shell must have 2. 1, 2. And we're done. That's it for this video, guys. I hope you've learned. If you have, please help me hit the like button. If this is useful, do share it with your friends and do subscribe. I will be producing more videos. See you guys in the next one.